What organ do you think this is? Lung. Okay, and this is probably back at that same as that last slide, just up closer, higher power. And this is lung tissue in here. And you notice how different it looks? Because we're looking at what? Well, how old is this individual? It's an embryo, isn't it? It's an embryo. And so, have these alveoli ever had air in them?
No.
No, they're collapsed, deflated alveoli. This is an embryonic, uninflated lung. I think these are developing airways and stuff.
What's
Okay.
the clear pathway?
Out here, I think when it was prepared that it pulled the visceral pleura away from the parietal pleura, and this should be a potential space, and here it's a real space. I think that's part of the preparation, the shrinkage that comes when you dehydrate and make specimens sometimes. Okay? Now, point being, when an infant is born, that first breath is a gargantuan effort. Okay? Over at UCD, they set up an experiment and showed it. They took a fresh pair of dog lungs and got all of the air out of them. Now that's almost an impossible thing to do, but what they did was they took a pair of dog lungs, rinsed them and filled them with carbon dioxide, and then diffused the carbon dioxide out and ended up with totally collapsed lungs without the residual volume at all in them. And then they put them in a big chamber, a big clear plexiglass chamber that they could lower the pressure on, like you lower the pressure in your chest when you breathe. And then started lowering the pressure, and you could see a gauge showing the pressures that went down, down, down. It went from 0 to -1 to -2 to -3 to -5. The lungs just sit there, -6. And I don't remember totally how far it went, -8, -9, somewhere like that, before alveoli started to inflate. The first time of inflating these alveoli, the first breath of that newborn infant, is a gargantuan effort. And we're all sitting there in a group, 100 of us, around this big plastic box, watching these lungs suddenly start to go pop, 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 and you see alveoli start filling up, and all of a sudden the lungs start expanding up around, I don't know, 8, 9, 10 millimeters of mercury, negative. And then as soon as they were inflated, they let the pressure go back to 0, and now 1 millimeter of mercury inflates the lungs. After the first breath, breathing is easy. Following what I'm saying?
Yeah.
Tremendous difference. Okay. Also, what this slide brings to mind is in the years I got to participate in autopsies at the coroner's office, every once in a while, and you see it in the paper, you know, they find a baby somebody chucked under a bush. Okay, or in a dumpster or something, and it gets brought into the coroner's office for autopsy. Right here is a critical slide that they make at the coroner's office out of that autopsy. And that slide right there determines the kind of charges that would be pressed against that parent.
Well, if it's taking a breath yet or not?
Whether this is collapsed and they could claim it was a stillborn, or whether they're inflated and it's murder. Okay? A big difference comes from making an understanding that slide of the lung tissue. The structure in whose cavity the pointer is circling? Bronchiole. Okay? Because these structures are what? Alveoli. And this tissue is what, do you think? Can't tell, but you should know. Good. Smooth muscle. I hear it. Absolutely. So we got smooth muscle, and here is some little, what, columnar epithelium? And so this is a bronchiole. No cartilage. So it's a bronchiole. And I look around and I see maybe alveolar sac somewhere, you know, up here maybe. But a lot of good alveoli. A lot of good alveoli in that particular field of view. The structure filling the field of view is an artery. Artery. What's your clue? What tells you it's an artery? Bingo.
Elastic.
I hear it, the internal elastic lamina. Look at that. Beautiful internal elastic lamina. And in here, smooth muscle and elastic fibers, right? Look at all the elastic fibers in there. They're white for some reason on this slide, the way this particular slide was stained. Okay, tissue? Blood. Excellent. Okay. Cavity occupied by the pointer. Alveolar sac, maybe the end of an alveolar duct. Maybe this is an alveolar duct. Okay, hard to see. But there must be an airway right up here. What is the airway that must be right up there? Must be a bronchus. Why? Hint, hint, a little cartilage plate or ring. Right? Very good. What's this? Not quiet again. You guys know that. Look at it. We're fairly low power here. Looks to me like a mucus tubule. Okay? I think there's a little mucus tubule. There's some glandular stuff there.
I was going to say cirrus sinus. That's not the same.
No, cirrus sinus would not have the clear cytoplasm towards the lumen like that does. Cirrus sinus would be a ball. This would be like a tube. Okay, looking at some thick section again. What do we have here? Looks like an alveolar duct here. Bronchiole. Here. I think the way this is made, that's a vein, pulmonary vein. Very thin wall. It's away from the airway. So I'm kind of guessing that is a vein. Okay. Identify this structure. Alveolus. Okay. And it opens in. There's another alveolus next to it. And we've gone through this now. What's all here, haven't we? Right in there is simple squamous type 1, basement membrane, endothelium, red cell, endothelium, basement membrane, simple squamous type 1, lumen of the next cell, right? Lumen of the next alveolus. Going across there. Okay. A lot of stuff through there. 2 respiratory membranes back to back, right? Look at this. So what have they done here? Some color, some dye somehow in here. Okay, this is an alveolus. Okay, those little lines are the capillaries. They've taken a piece of lung and injected into the circulatory system colored gelatin. And then they made the slide. And so they sliced. And so like here's through the middle of an alveolus, and here's looking at the top of an alveolus, and you see the network of capillaries that winds its way all around. Look at the capillary networks over all these alveoli where you see those tops. And that's where all the respiratory membranes are. That's where all the gas exchange takes place. Great, huh? Well, I don't know if they did both red and blue gelatin is what I think they did. I think they ran into the artery some red and into the veins some blue, and they kind of merged together, and I don't see quite the point in it. But I'm sure that's what they did. I've read the cheat sheet before.